Alright, so we have another article about domain adaptation, but this time the problem is biomedical question answering. So probably we may have a domain shift problem, then we should resolve it with techniques of domain adaptation. So this article is about domain adaptation. And it is in 2017. Factoid question answering has recently benefited from development of deep learning systems. Neural network models outperform traditional approaches in domains where large datasets exist, such as Squad for Wikipedia articles. However, these systems have not yet been applied to question answering in more specific domains, such as biomedicine, because datasets are generally too small to train a domain specific language or deep learning system from scratch. For example, BioASQ dataset for biomedical question answering comprises less than 900 factoids. So in this work, we adapt a neural QA system trained on a large open domain dataset to a biomedical dataset by employing various transfer learning techniques. Our network architecture is based on a state-of-the-art QA system extended with biomedical word embeddings and a novel mechanism to answer list questions. In contrast to existing biomedical question answering systems, our system does not rely on domain-specific ontologies, parsers, or entity taggers, which are expensive to create. So it's very easy. Your source domain is it's open domain dataset, this dataset. Your target is another dataset. But this is a weird approach not weird. It's a naive approach because it's too general. It could be anything. That's why we need domain generalization. That we have multi-source, that you can understand what you are transferring, because if you go from Squad to BioASQ, you can transfer anything. You don't know if it is because here you have more about genes entities and here about protein entities, or is it because the sentence is long, or is it because so the natural thing is to do domain discovery instead of just setting everything before even starting the algorithm. So we should assume that you don't know the domains. That's more natural. Of course, it's your software gets more complex and bigger. So we have extractive question answering system. You have context, you have question embedding, and then you get the start and end scores and probabilities. So it's very classic question answering system and solution. And for embedding, they concatenate, I think, glove, character embedding, word2vec, and of course they use UMLS. This is very important in biomedical literature, because you have our ontology and it's very useful information. And then you get the start and end probabilities. And for decoding, they define a threshold. If it is bigger than that, you get the list of answers. So to avoid catastrophic forgetting during fine-tuning, the idea of catastrophic forgetting comes from continual learning, also known as lifelong learning, which I've explained in a different video. And then the final loss is just a combination of this regularization and your original loss. So these are data set. You go from this source to this target domain. in your list of F1 scores conclusion. So we describe a deep learning approach to address the task of biomedical question answering by using domain adaptation techniques. Our experiments reveal that mere fine-tuning in combination with biomedical word embeddings yields state-of-the-art performance on biomedical question answering. Despite a small amount of in-domain training data and a lack of domain-dependent feature engineering, techniques to overcome catastrophic forgetting, such as forgetting log cost, can further boost performance for factoid questions. Overall, we show that employing domain adaptation on neural question answering systems trained in large-scale open domain datasets can yield good performance in domains where large datasets are not available.